Okay, folks, we're working off of the bottom of page 22 of our hot pink book. So we're just going to look at some of the reactions of alcohols. And the first one, or the main one that we're interested in, is a mash reaction. So we've seen that last year. So I'm hoping in your head you are now saying metal plus acid gives you salt and hydrogen. So example would be magnesium plus hydrochloric acid goes to magnesium chloride. So magnesium is group 2 plus 2 charge. Chlorine is -1. So I must have 1 +2 and 2 -1s for this to be a formula, if you didn't know what it was already, plus hydrogen gas. So to do my quick balancing, I have a look, my magnesiums are balanced as I stand. I have Cl2 here, so I have to put 2 HCl here, and then that also takes care of this. Now, in terms of alcohols, alcohols behave as extremely weak acids. So a weak acid is, in terms of Bronsted-Lowry, what would you say? So I'm hoping you're shouting at the screen that they are poor proton donors. So any alcohol is essentially forced to donate protons, and it is going to do that by reacting with a very reactive metal. And it's done, so we use something like group 1 metal. So the setup that I had the other day in lesson was to show you what would happen if we put a drop of sodium into a little beaker of pure ethanol. So we go back to our mash reaction, because this is the one we're showing you. So in this case, the metal is going to be sodium. The acid is going to be, we're going to use ethanol, C2H5OH, and this is the acidic hydrogen. Now, these hydrogens exist, but it is the H on the hydroxyl group which is the acidic hydrogen. So we are going to combine this, and I'm putting a negative charge because it's an ionic interaction, and a sodium is going to attach to it, and I'm going to make hydrogen gas. So I have to look a little bit at my balancing now. So currently I have 2 H's here, so I really need to put 2 here. If I do that, then I need to have 2 of these, and as I now have 2 sodiums, I put 2 here. Now, you have to know the name for this particular thing. Apologies. So this is called sodium ethoxide. So the salts of an alcohol get the name. The only one you'll have to know is for ethanol, but ethoxide. So that is the salt of ethanol. It is a need to know. Okay, so you have to know that ethoxides are the salts that you get from ethanol. Now, we have to go back to when we did the very end of acids and bases theory. So if an alcohol is a weak acid, what can we say about its conjugate base? So the salt is a strong conjugate base. And what does that mean when you're looking at an equation? Well, that means that the reaction will go to the right-hand side. So you will make the salt. Okay, so again, this is linking back. So a weak acid is going to have a strong conjugate base. So going on to page 24, there is a formula. The iPad doesn't like being touched. So page 24, you have an equation which is essentially C2H5OH goes to C2H4 plus H2O, and it has Al2O3, and it has heat under here, and it's asking you some questions. So what is this type of reaction? We did it when we made ethene. So this reaction is what's called an elimination. What does that mean? It means that there is a small molecule removed, usually water. And for the examples that we have on your course, that is the case. And there's the formation of something with the double bond. Which in this case is the ethene. So that's how you know it's elimination. There is no subtraction in chemistry, so instead of subtraction we use the word elimination. So you can call it elimination in an answer if you have to describe it, or you can call it dehydration, because that's what's happening. You're dehydrating the ethanol to get ethene. Now, in terms of the change in geometry, so I'm going from this to this. So I am, again, because I'm an optimist, very hopeful that you know that these guys are tetrahedral in geometry and these guys are now planar in geometry. So that is our change in geometry. It goes from tetrahedral, the joy being left-handed, goes from tetrahedral to planar. And we've seen this particular reaction in the production of ethene. So if we flip the other way and we now want to make alcohol, what type of reaction is this going to be? So we're flipping the equation above, and the only thing we're left with, so C2H4 plus H2O becomes C2H5OH. So in terms of type of reaction, this is going to be an addition because we are adding two things together, or you can call it a hydration because you're adding water. So we've now done elimination, addition, hydration, and when we looked at haloalkanes, we made substitution. So it's just reversing the geometry. So we're going from planar in C2H4 to tetrahedral in ethanol. Okay, so note that I'm showing all the bonds in the OH group. That's really important. So the new little bit of this is, if we wanted to convert an alkene, so if we wanted to convert C2H4 to C2H6, what would we do? What would our reagent be? So the difference between these two molecules is H2. So we would form an addition this is called an addition reaction. Now here is a new thing which will wreck your head a little bit. We can also call this a reduction. And you know from oil rig, reduction, oxidation is loss, reduction is gain. Reduction is an increase in oxidation number. Or sorry, decrease in oxidation number, and we would put the electrons on the left hand side if we were writing half equations. Now it is a reduction and you will need to know what's used. So we will use a nickel catalyst and heat is going to be the reagent. So this is a piece of new learning and we are going to see a reduction again. This is a need to know for you. Because we're adding hydrogen, it can also be called a hydrogenation. So this is what they use to make margarine. It is a hydrogenation reaction because you're adding hydrogen. So you have three types of descriptions for this type of reaction. If I was going to go in terms of what are the top three, this would be number one, if it'll ever stay big for us. So this would be number one, this would be number two, and this would be number three. So again, from our geometry changes would be from an alkene, which is planar, moving all the way to tetrahedral. Terms of our geometry. So that's where we're going to leave that particular spot for now, and there'll be another video on the ionic addition mechanism, which is a higher level topic.